Yes. If the graph is a parabola, so if it's a U-shaped symmetrical curve, then you automatically, once again, to tell if it's quadratic, if you look at the graph, and if you notice that it's a parabola and it has a U-shaped symmetrical curve, you automatically know it's a quadratic relation. If the equation has an x squared term, you know it's going to be quadratic. And if you calculate the second differences, if they're all the same, if they're constant, if it's the same number every single time, then you know it's going to be quadratic. It's going to be quadratic. So the equation, when it's written in standard form, is y equals a x squared plus bx plus c. Okay, do you remember when we were doing the graphs on Desmos and we looked at whatever number was in front of the x squared term? So for example, if we had y equals 1x squared, or if we had y equals negative 1x squared, do you remember what this coefficient, so the number in front of the x squared term, what did that tell us about the parabola? Do you guys remember? If it was positive, what did it tell you? If it was negative, what did it tell you? The number in front of the x squared tells us what? If the number is positive, what does the parabola look like? How does it open? If it's positive, it opens up. So if a is positive, right, this number in front of x squared is positive, it opens up, so it looks like that. If a is negative, how does it open? Down. It looks like that. And there was something else we related to opening up and down. You guys talked about this in one of your assignments. Okay, so if it opens up, yeah, does it have a minimum or maximum y value? Would this be the lowest or the highest point? So it would have a minimum y value. If it opens down, it has a maximum y value, right? You're looking at the highest point, the maximum point it can go. It can't go higher than that, and this one can't go lower than this. So let's say I give you a graph of a parabola. I know it's hard to see this, but what are the different parts of a parabola? Somebody mentioned one of them earlier. What is this part of the parabola called? This is called the vertex. You need to know this for your test. If I say find the vertex of the parabola, that's the point where the parabola changes direction. Okay? So in this graph, I know you can't really see, the vertex is located at it's negative 0.2 and negative 3.2. So I have decimals here, but we're just looking for the coordinates. So it's located at negative 0.2 is my x value, right? This is the x-axis. And then the y value is negative 3.2. I'm not going to give you decimals on the test, but I just drew something else that you need to know about. What is this line that I just drew? What is this called? Axis of symmetry. And the axis of symmetry goes through the vertex. So what does it share? What value does it share with the vertex? If it's going through the vertex, what value does it share with the vertex? Is if I ask you for the equation of the axis of symmetry, or am I asking you for the x value or the y value? It's always the x value of the vertex. So if you know the vertex, then you automatically know the axis of symmetry, right? So the x value, the axis of symmetry, x would be equal to what in this example? What is the x value of the vertex? Negative 0.2, so that is my equation of the axis of symmetry. On your test, if you don't put x equals, I'm not going to give you full marks because you need to identify that it's the x value, right? It goes through, and you can look here, it goes through the x-axis. Here's our x-axis, okay? So since we're still talking about the vertex, we just discussed this. Does this parabola have a maximum or minimum value? It opens up. Is it going to have the lowest point or is it going to have the highest point? The lowest point, which is where? On the vertex, right? Minimum What is the minimum y value? What is the lowest point that it goes? It can't go past this point. What is that point? You can look at the vertex, right? And it's the y value, I'll put in brackets here, of the vertex. So we just look at the vertex, and the minimum y value is negative 3.2. On my graph, it's not going to go, the parabola will not go lower than negative 3.2 on the graph. Okay, so there's two things that the vertex tells you. It tells you the axis of symmetry and the minimum or maximum value. What other parts of the parabola can we identify? It was on your quiz. We can look for x-intercepts. Is it passing through the x-axis anywhere? Here and here. So what are the x-intercepts? You're just looking for the coordinates of when it hits the x-axis, and these are decimals, so I'm just going to look on decimals and see. This x-intercept is located at 0.60, and this one here is located at negative 1, 0. Those are the two coordinates for the x-intercepts. What was another name for x-intercepts that you learned in your book? Starts with a Z. The zeros. They're called the zeros of the relation because the y value is always 0, right? If it's on the x-axis, then y is always 0. What else? We have the x-intercepts. Is there any other point on this parabola that I can identify besides the x-intercepts? What else? Does it hit the y-axis? Right here. This is your y-axis. So when does it hit the y-axis? At 0, negative 3. That's that point right here. You'll need to identify a y-intercept as well. So you have to identify the vertex, the maximum or minimum value, the axis of symmetry, and the x-intercepts. So you'll be given a table of values with numbers filled in, and you have to say if it's quadratic, linear, or neither, okay? By using the table. So what are the things that you're going to do to figure out if it's quadratic, linear, or neither? What do you have to find? First differences, and then if those are not the same, then you have to find the second differences. And if the second differences are the same, then it's quadratic. If the first differences are the same, it's linear. If neither of these differences are the same, then it's neither. It can't be linear or quadratic.